Hello everyone, this is Madhavi, Assistant Professor from Welltech Multitech Engineering College. Okay, today we'll look on to the topic called the applications of stack, whereby there are so many applications, um, but I'm going to deal on with the two major topics called how to convert the infix expression to the postfix expression using the stack concept and how to evaluate the given expression using the stack concept. So before dealing with this topic, let's see the uh, basic conceptual uh, concept of the stack. So when we take a stack is a linear data structure whereby the data elements will be ordered in the linear manner, and it is going to follow some principle which is called as the last in first out, just in short called as the LIFO, last in first out. So this is how the stack will be represented, and initially the stack will be an empty stack whereby no elements will be present inside the stack. And when we are going to add a new element onto the stack, and whenever we are going to remove an element from the stack, both the operations will be carried out only from one end called as the top. So a stack is going to contain only one end called as the stack. Okay, so the top of the stack is being represented by using the pointer. So when we are going to add an element, it will be pushed onto the stack, which means it will be added onto the stack. And when we want to remove an element from the stack, we'll call that term as the pop. So the two major operations will be carried out in the stack called as push and pop. Push refers to adding an element onto the stack, and the pop refers to removing an element from the stack. Okay. So this is a basic thing that we have to look on. Next is this is the basic stack data structure. First, initially it was an empty stack, so no elements have been added onto it. So which means that there is no top pointer over here. Next, and a new element called as 1 is being added on to the stack. So that will refer to as the push. So a push operation is performed here. We are going to insert an element 1. So whatever the element that you are going to add will come to the bottom of the stack. So next, another new element has been pushed on called as 2. So it will be placed over the first element. Next, a third element has been inserted onto the stack. So this 3 will be placed over the top of the 2. Next, so when we want to delete an item or when we want to remove an element from the stack, that operation we'll call it as the pop. Okay, so according to the stack concept, LIFO principle is being followed out. So whatever the elements that has been inserted at last will be taken out first. So 3 was the last element which has been which has came inside. So the 3 element, that is the third element, data element called as 3 has to be popped out. So this is the basic concept of how this stack data structure works. So we'll directly move on to how to convert the given infix expression to the postfix expression. Before converting the infix to the postfix, we have to know how the postfix expression would be and how the infix expression would be. So this is an infix expression given here as A plus B star C. Here A, B and C are the operands and plus and star are the operators. So we can call this thing as an expression. Expression is a combination of the operand and the operators. So given an expression, we are going to call this one as an infix expression because the operator lies in between the operands. So the plus comes between the A and B operand. The star lies between the B and C operand. Okay, so this is an infix expression. So this infix expression will be converted to the postfix expression like this way, where the operators must be placed at last. So the operands will be first displayed, and at last the operators will be placed. Okay, so we are going to convert this given infix expression to the postfix expression with the help of this stack concept. So we'll see that procedure with an example. So, as we all know, an expression might contain so many operators, and each and every operator will have its own precedence level. So, according to the operator precedence, when we consider these two operators, that is the star and plus, this multiplication operator will be having more higher priority or more higher precedence than this plus. Okay, so when we take this example, 5 plus 2 plus 3. So here we are going to have the two operators called as plus plus, which is of the equal precedence. So according to the associativity, if we have the operators of the same precedence, we can solve it from the left to the right according to the associativity rule. So first we can solve this 5 plus 2, which is nothing but 7, and then 7 will be added on with this 3, which will get it as 10. This is the another example being given here. We are going to have two different operators here, plus and star. Here, when we see the operator precedence table, this star will have the more higher priority than this plus. Yes, so the star will have more priority than plus. So this multiplication operator must be performed first. So this term 2 star 4 must be carried on first. So 2 4s are 8, and that 8 will be added on with this 1. So we'll get it as 9. But in spite of that doing, if we have it like this, like 1 plus 2 is 3, and 3 star 4 will be getting it as 12, which is a wrong answer that we should not consider it. So we should act according to the operator precedence table whenever we solve an expression. So an expression, in some cases, an expression can have some parentheses also, like open and close parentheses. So when compared to these two above operators called as star and plus, the parentheses will have the more highest precedence when compared to all other operators. So according to this rule, the parenthesis term must be solved first before evaluating any other operators. Here 1 plus 2 is given inside this parenthesis, so we have to solve it first. So 1 plus 2 is 3, 3 4s are 12. Next, when we take the second example, here inside the parenthesis, whatever the expression is being given, that we have to solve it first. So here we have the term called 1 plus 2 star 5 plus 1. But inside this parenthesis, you have two operators. Check out here, plus and star. So which has the highest precedence here? Star. So first this term has to be evaluated. 2 5s are 10, and this 10 will be added on with this one, which is 11, and 11 will be added on with this one, which is 12. So 12 star 3, which is nothing but 36. Next, there will be some cases like you will have multiple parentheses. That is, if you have more than one parenthesis given here, the inner parenthesis must be solved on first before evaluating an outer parenthesis. So according to this rule, here we have the 5 plus 1. So, okay, this is an inner parenthesis expression. So we have to solve this one first. 5 plus 1 is 6. Okay, so 6, that will be multiplied with this 2, because the star has the highest precedence here. So 6 2s are 12 plus 1 is 13, 13 3s are 39. This is how in general we'll evaluate an infix expression. Now coming to our topic, which is nothing but we are going to see how to convert an infix to the postfix expression. These are some of the examples. If you check out here, you have the examples. The first example, if you see here, the operate, that is the operand will be displayed first and then the operators at the last. That is called as postfix. In a postfix expression, the operators will be placed at last. Okay, so these were some of the examples if you see on these. And if you check out these expressions, there will not be any open and close parenthesis in this expression. Okay, even though when we have in the infix expression, it should not be displayed when we are writing it in the postfix expression. This is one rule. Okay, and so now we'll see how to evaluate this postfix expression. And if you want to evaluate this expression, and we are going to use the concept called stack. So this is an algorithm like how to convert the infix to the postfix expression using the stack concept. So first step, the first and the foremost step is that we have to read all the symbols one after the other which is being given to us. Okay, so an infix expression will be given to us. We have to read the each operand and the operators one by one as usual from left to right. Next, when we are reading the symbol, if that symbol is an operand, what we have to do is that we have to place it to the postfix expression. And suppose if a left parenthesis has been identified, we have to push it onto the stack. And if we are reading the symbol called as right parenthesis, we have to pop all the contents of the stack which is being present inside this open and close parenthesis, and we have to pop it out from the stack and we have to push it into the postfix expression. And you'll be clear when we are seeing the example. Okay, this is just an example, and this you could be able to understood when we are working out with an example. And so these are the general rules or the general steps that we have to follow on. And suppose if we are going to read the operators like plus, minus, star and slash, we have to we can insert or push all these operators onto the stack. But there is one condition like the higher priority can be placed, higher precedence operators can be placed over the smaller precedence, but not the vice versa, which means the smallest priority operator cannot be placed over the higher priority. In such case, what we have to do is that we have to pop that particular current operator from the stack and we have to push it onto the postfix. Okay, suppose, and if all the operators and the operands are pushed onto the stack, and that is if all the operators and the operands are pushed onto the postfix expression, and after that also if there are some operands or operators left over in the stack, you can surely pop all the items from the stack and push it onto the stack. So these are the general algorithm that we are going to follow on. So this is an example. If you see this example, this is the given expression. Okay, a plus b star c minus d slash e. This is a given expression to this. We have to convert this infix expression to the postfix expression. With what? Means with the help of the stack concept. Okay, so in between the stack concept has been inserted. So if you see here, A is an operand. Okay, so what we have to do? Whatever, if it is an operand, according to the algorithm, we have to push it on to the postfix. Okay, so A is an operand. So if you see here, A is pushed onto the postfix. Next, we have to read the second character. Okay, so here the second character is plus. Plus is an operator. If you are going to read an operator, it has to be pushed onto the stack. If it is an operand, you have to place it onto the postfix. If it is an operator, we have to push it onto the stack. Okay, so next character that we are going to read on is an operand called as B. So B has to be placed onto the postfix. Okay, next here comes the star. Star is an operator. So with no doubt, you can place it onto the stack. Okay, so see here, the star is placed onto the stack. And as I've told you, the higher priority operator can be placed over the lower priority, but not the vice versa. So this operator is being placed in a correct way. Okay, so next we are going to scan the next character, which is nothing but the C. C is an operand, so you can directly you can directly place it onto the postfix. Okay, so C has been moved here. Next comes the minus. Okay, so if we are going to place this operator onto the stack because it is an operator. Okay, so if it is an operator, we have to place it onto the stack. So minus, but if you see here, minus is a lower priority and star is an higher priority. So there is a rule like the lower priority should not be placed over the higher priority. So if it happens, so what we have to do? We have to pop all the operators from the stack and push it on to the postfix. Okay, so star will be taken out first and it will be pushed onto the postfix. Next, this plus will be popped out from the stack and placed onto the postfix. Okay, and next this minus symbol will be inserted onto the stack. Okay, next is the D. D is an operand. If it is an operand, you can directly place it onto the postfix. Okay, so the D has been placed here. Next, we are going to read the next character called as the slash. So it is a division symbol. So when we see here above the minus, the division symbol has been added, which means that it is a correct one because the higher priority can be placed over the lower priority. So it is being pushed in a correct way. So next is E. E is an operand. We have to directly place it onto the postfix. Okay, so he has been placed here. Next, now the infix expression is all over. There is no other operators or any other operators or any operands have been present here. Okay, so and according to the last step in an algorithm, what it says, whatever once we have completed all the infix, if the infix has been moved on to the postfix and if some operators have been pending in the stack, we can pop that operators from the stack and place it onto the postfix. Okay, so according to that, you can directly move this slash, that is the division symbol, onto the postfix, and next you can directly move this minus symbol onto the postfix. So when we see here, this is a given infix expression and it has been converted to the postfix expression with the help of this stack concept. So the general thing that we have to remember is that if it is an operand, you can directly place onto the postfix. If it is an operator, we have to push it onto the stack. And the rule here that you have to follow is that the higher priority operator can be placed over the lower priority, but not the vice versa. If it is so, we have to pop all the operators from the stack and place it to the postfix. Okay, so this is an example for how we have to convert the infix to the postfix expression. So this is another example. This was an expression given to us. So first, I have pointed here the arrow mark. So which is going to tell you like that we are going to scan it at first. Okay. So first A has to be scanned. A is an operand. If it is an operand, you can directly push it onto the postfix. So A has been moved onto the postfix. Okay. Next we are going to read the next character, which is nothing but the star. Star is an operator. If it is an operator, we have to place it onto the stack. It is being placed. Next. The third character that I am going to read on is a parenthesis. Okay, it is a left parenthesis. If it is a left parenthesis, again I am going to push it onto the stack. Okay. Next is the B. B is an operand. I have to place it onto the postfix. Next, followed by B, I have the plus. Plus is an operator. If it is an operator, you have to push it on to the stack. And next step, we are going to scan the character C. So C is an operand. If it is an operand, you can directly place it onto the postfix. Next, we are going to read the character called as plus. So plus is an operator. We all know, like, if it is an operator, you have to place it onto the, you have to push it onto the stack. But already plus is there in this stack. If it is of higher priority, it's of no sense. But if it is of an equal priority, the thing that we have to do is that you have to take it out. That is, we have to pop that plus from the stack and place it on the postfix. Okay, so initially it was ABC. You cannot place this equal priority operators one over the other. So I'm going to push, that is, I'm going to pop that one plus from the stack and place it to the postfix. Okay, next I am going to read the character called D. D is an operand whereby I can easily place it onto the postfix. Next is the closed parenthesis. Whenever we are going to find the closed parenthesis, we have to place it onto the stack, and whenever we encounter and write parenthesis, whatever the operators being present inside this open and closed parenthesis, we have to place all those operators. That is, we have to pop all those operators and place it onto the stack. Okay, so it was being placed onto the stack, given here as like this one. Initially it was D, then I have popped the plus from here from the stack, and I have popped the star from the stack and placed it at last. So this was the final expression that I have got it out when I'm going to convert this infix to the postfix expression with the help of this stack. So this is how it works. Next, we'll see how to evaluate an postfix expression. So a postfix expression can be evaluated by the following steps. First is that we have to read the expression. An expression will be given to us. We have to scan it or read it from the left to the right. And if we have seen a number, if we are going to scan the thing, and if that is an number, that is, if it is an operand, we have to push it onto the stack. But when it is an operator, what we have to do is that we have to apply this operators to the first two numbers being present in the stack. That is, we have to take that first two numbers from the stack. We have to pop the two numbers from the stack, and we have to apply this operator, and we have to push that result onto the stack. So this will be clear for you when we see with an example. So this was the postfix expression given to us. 6, 5, 2, 3 plus 8 star plus 3 plus star. I'm going to evaluate this expression, this postfix expression, using the stack concept. Evaluate in the sense, I'm going to solve this expression. Okay. So according to the algorithm, first 6 will be read out. Okay. So the 6 will be placed onto the stack, which comes at the bottom of the stack. Next, we have to read this second character, which is nothing but the 5. So this 5 has to be again inserted onto the stack. If it is a number, we have to insert it onto the stack. Next is 2, which is again a number, and 3 is also a number, which I'll be inserting it onto the stack. Okay. Next, the next character that I'm going to read is an operator, which is nothing but plus. If it is a plus, what I have to do is that I have to take, that is, I have to pop the first two elements. That is, if I'm going to pop, which one comes out first here? 3 and 2. So I have to pop these two elements, 3 and 2, and apply this operator. So 3 plus 2 will be 5. So I have written here as 5 and I have to push it onto this stack. Next, the next character that I am going to read is here 8. So 8 is an number. So if it is a number, I have to push it onto the stack. So I have pushed here. See here 8 has come. Next is the star. Star is an operator. If it is an operator, what we have to do? We have to pop the two elements from the stack, which is nothing but 8 and 5. You have to pop it out and apply this operator, and we have to push the result onto the stack. So I'll be popping out this 8 and 5 and apply this operator, which is nothing but 8 5s are 40, and I have to push it onto the stack instead of this 8 and 5. So the resulting stack will be like this. And next is I have to read the next symbol, which is nothing but plus. So plus, if it is an plus, if it is an operator, what we have to do? We have to pop the two operands from the stack, and we have to apply this plus over these two operands, and we have to push the result onto the stack. So 40 plus 5 will be popped, 40 and 5 will be popped, and this plus operator will be applied. So we'll be getting 40 plus 5 is 45, and it will be pushed onto the stack. Next is I'm going to read the next number, which is nothing but 3. So 3 is an operand. If it is an operand, I can push it onto the stack. So above 45, I'll place this 3. And next is the operator that next thing I'm going to scan is plus. Plus is an operator. If it is an operator, you have to pop the first two elements from the stack, which is nothing but 3 and 45. I'm going to pop it out and apply this plus. So 3 plus 45, which is nothing but 48, and I have to push that result onto the stack, and this will be the result stack. Okay, next, at last I'm going to read this character called as start. So I have to read each and every characters being given in the postfix expression. Okay, so the last character that I am going to read on is the star. So star is nothing but the multiplication. So if we are going to encounter an operator, we have to apply it, that is we have to pop the two elements from the stack, which is nothing but 48 and 6 will be taken out from the stack, and I'll be applying this star operator 48 into 6, which is nothing but 28. So that result has to be pushed onto the stack. So this is how we have evaluated the given postfix expression. So we have seen like how to convert an infix to the postfix using the stack concept, and how to evaluate the given postfix expression using the stack concept. Thank you.